Hello guys, welcome back to my lessons. Today we're going to talk about geometric sequences and geometric series. Remember we talked about arithmetic sequence and quadratic sequence. Now we're going to talk about geometric sequences. For series we've spoken about arithmetic series, and then today we're going to talk about also geometric series. So a sequence, if you see numbers in order and they are separated by commas, that is a sequence. But in geometric sequence, there is a common ratio between consecutive terms. Remember, in arithmetic sequence, there is a common difference. In quadratic sequence, there is a common second difference. So in geometric sequence now, there is a common ratio. What do we mean? If you take term 2, you divide by term 1, you're going to get the ratio. So for an example, if you are given a sequence, you're not told whether it is a quadratic, an arithmetic, or geometric sequence. What you do is you take the second term, you minus the first term, take the third term, you minus the second term to check if there's a common difference. If there isn't a common difference, what you're going to do is divide. Take the second term, divide by the first term. You take the third term, you divide by the second term to check if there isn't a common ratio. Now with quadratic sequence, how you're going to see it, you take the second term, you minus the first term, the third term minus the second term, and then the fourth term minus the third term. And then from there, if the numbers are not the same, you continue to minus. You take the difference that you found, you take the second term of that difference, you minus the first term of the differences. And then you take the third term of the difference, you minus the second term. If you find the second common difference, that is quadratic sequence. So now let's move on to geometric sequences. To get the ratio, you say term 2 divided by term 1, and then term 3 divided by term 2. If you find a common ratio, that is geometric sequence. So we have a general formula in geometric sequence as well. This formula will help you to find any term that you want in the sequence. So the general formula is Tn is equals to AR exponent n minus 1. So both n minus 1 are exponents. So what do you do? Let's look at the sequence 5, 15, 45, 135, 405. If you take 15, you divide by 5, you get 3. 45 divided by 15, you get 3. 135 divided by 15, you get 3. 405 divided by 135, you get a 3. So there is a common ratio between consecutive terms. So now what do you do if they ask you to find the next 3 terms in the sequence? If you look at the sequence, what they do is they multiply the previous number by 3 to get the next number. What you're going to do to get the next term, you're going to multiply 405 by 3, you're going to get 1215, which is the next term. And then to get another term, you're going to say 1215 multiplied by 3, you get 3645. That is the next term. And then you're going to take 3645, you multiply by 3, and then you get 10,935. That is the next third term. So those are the next 3 terms. Now the general formula specifically for this sequence that we're given, you take the general formula that I've given you, Tn is equals to AR exponent n minus 1. And then what do? You substitute for specifically for this sequence. Tn in brackets 5, put it in brackets or put a multiply sign after 5. And then 3 in brackets exponent n minus 1. And then that is our general formula for this specific sequence. So we can use this formula now to find any term. And then they say find term 9. You're going to use the formula Tn is equals to in brackets 5 and in brackets 3 exponent n minus 1, and then you're going to substitute the n, you substitute 9, and then 5 in brackets, 3 in brackets, exponent 9 minus 1. If you put that on a calculator, the answer is going to be 32,805. Don't forget the 9 minus 1 are exponents of 3. So that is all about geometric sequence, and then you can use those formulas to answer the questions. So now let's look at the geometric series. When we add terms of a sequence together, we find a geometric series. So a sequence, the numbers are separated by commas, but in series, the terms are separated by a plus sign. So we have 25 plus 50 plus 100. And then in a geometric series, there is what we call a finite series, a series that ends at a certain term. So in this case, this geometric series ends at term 6, as you can see, to 6 terms. So term 1 is 25, term 2 is 50, term 3 is 10, then from there to term 6. So let's check the common ratio. 50 divided by 25, that is 2. 100 divided by 50, that is 2. So we have our common ratio. The next 3 terms, 100 times 2, we get 200. 200 times 2, 400. 400 times 2, 800. So 200, 400, and 800, those are our next 3 terms because they multiplied the previous term by 2 to get the next term. So determine term 5. Term 5, we already have term 5, which is 400. But then if maybe they asked about a term that you cannot find by just multiplying by 2, what you're going to do is you write the general formula Tn is equals to a r exponent n minus 1. Then you substitute specifically for this series. Tn is equals to term A is equals to 25 in brackets, R the ratio, which is 2, and then exponent you're looking for term 5, and you substitute with 5, and then minus 1. If you put that on a calculator, you're going to get 400. Now in geometric series, they might ask you determine the sum of the first 6 terms of the series. So the formula of finding the sum, it is Sn is equals to a in brackets r exponent n minus 1. The minus 1 in this case is not an exponent, but it's r exponent n only, and then minus 1 on the side, divided by r minus 1. For what? For r is greater than 1. And then we have another formula, Sn is equals to a in brackets 1 minus r exponent n, and then divided by 1 minus r, for r is greater than 1. So you can use either of the formulas to get your sum, whereby a is the first term, r is the ratio, n is the number of terms. In this geometric series, we have 6 terms. And then the Sn, it is the sum of the terms that maybe they're looking for. So to calculate the sum of the next 6 terms, let's take this formula. Sn is equals to a in brackets 1 minus r exponent n close bracket divided by 1 minus r. And then we substitute for n, we're looking for terms, the sum of the 6th term, sum of 6 terms, and then a is 25 minus 1, r is, the ratio is 2, exponent n, it is 6 divided by 1 minus 2, because the ratio is 2, right? And then 2 exponent 6 on the side, that is 64, and then you substitute the 6 there. Sorry, I forgot to put the exponent there. There's it's not 26, but it's 2 exponent 6. And then S6 is equals to 25 in brackets 1 minus 64 in brackets, and then minus 1. And then S6 is equals to 25 and in brackets minus 63, because 1 minus 64 is 63 divided by 1 is equals to, if you put that on a calculator, 1575. So they might ask you again in geometric sequence to give the sum. They might tell you that this sequence has perhaps 7 terms, and they might ask you to calculate the sum of this the terms in the sequence also. I don't think it's always in a geometric series where they'll ask you to find the sum. So if they ask you to find the sum in the sequence, don't be confused. Just take the number of terms, substitute on n, and then substitute the ratio on r, and then and then find your Sn. The a, it will be the first term. Thank you so much for listening. Don't forget to subscribe to my channel, and I would really appreciate it.